Hello everyone, and welcome to our session on Exploratory Data Analysis, or EDA. It's a crucial first step in truly understanding your data before diving into complex modeling. EDA involves breaking down data into variables, analyzing each and their interactions. It focuses on finding anomalies, missing values, and correlations to gain insights before building any model. Exploratory data analysis is built upon three core components: effective data visualization, thorough variable analysis, and intelligent feature engineering. Together, they unlock hidden potential in your dataset. Data visualization helps us see patterns quickly. We use plots like scatter plots and histograms to understand distributions and relationships between variables. Feature engineering is about creating new, impactful features from existing data. Sometimes the initial features aren't enough, so we transform them to improve model performance. Feature engineering is vital because garbage in is garbage out. By creating useful features like moving averages, we ensure our models learn from the best possible information. Today, we'll dive into univariate and bivariate analysis to understand data distribution, spread, and variable correlations. We'll look at price, volume, and their relationships. In stock market data, we encounter key prices: opening, closing, high, and low. These are fundamental for investors to analyze market trends and make informed decisions. Univariate analysis examines a single variable to summarize its distribution and key characteristics. Its purpose is to understand central tendency, variability, and patterns within that variable. Key metrics for univariate analysis include measures of central tendency like mean, median, and mode. We also consider measures of dispersion, such as range, variance, and standard deviation. Other univariate metrics involve the interquartile range, understanding the shape of distribution through skewness and kurtosis, and using graphical representations like histograms and box plots. Kurtosis describes the tails of a distribution, indicating the presence of extreme outliers. Leptokurtic means heavy tails, mesokurtic is moderate, and platykurtic indicates light tails. Bivariate analysis explores the relationship between two variables, helping identify correlations and dependencies. We examine numerical versus numerical, categorical versus categorical, and numerical versus categorical pairs. For numerical versus numerical data, we use scatter plots to visualize relationships, correlation coefficients to measure strength, and regression analysis to model their interaction effectively. When analyzing categorical variables, we use contingency tables and chi-square tests. For numerical against categorical data, box plots and t-tests or ANOVA help compare group distributions. Graphical representations in bivariate analysis include scatter plots for numerical pairs, heat maps for correlations, and clustered bar charts to compare categorical variables visually. Beyond these, other statistical analyses include frequency distributions, showing how often values occur, and descriptive statistics like minimums, maximums, and percentiles to summarize data. You can explore further with resources available online. These links provide more examples and information to deepen your understanding of data analysis techniques.